significant digits in some of your science classes. I know in chemistry and things that you sometimes do them. I have slightly different rules on how we're going to use them in here, but it is mostly similar. So when I'm talking about significant digits or significant figures, what we are going to do is count all digits from left to right, beginning with the first non-zero digit. Okay, so we'll go from left to right, beginning with the first non-zero digit. If there is not a decimal point, we do not count trailing zeros. So let's jot down these rules and then we'll look at some examples and really explain what I mean by those. Let me see. I just want to know how many significant digits each of these has. So 0.042. If you look at what you just wrote down, it says you start with the first non-zero digit on the left. So the first non-zero digit on the left is 4. So how many significant digits does this have? Only 2. B, how many significant digits does it have? Just 1. You start with the first non-zero digit and then count things after that. C. This is my first non-zero digit, right? So we count everything after that. So it will be a 3. On D, as long as you have a decimal, you do count zeros that come after. So this would be 4. 9,200.0, that would be 5. But if I say 700, that's only 1 because there's not a decimal. We only use the first non-zero digit. Okay. Do you guys understand how we are counting those? In general, we are going to use significant digits in the next couple sections. When we're solving problems, your answer can't be more accurate than the numbers you began with. In other words, if I'm asking you to find the third side of a triangle, and I took the first 2 sides and rounded them to the nearest whole number, can you give me a decimal that's accurate to 5 places? No, because the first 2 numbers weren't that accurate. So we are going to be using this in answering our questions. We'll just give the same number of significant digits given in the problem. So for instance, if in the problem I had 2 significant digits on my sides, you would give me 2 significant digits for your answer. We are going to make a couple assumptions from now on. When I say right triangle ABC, unless I specify otherwise, angle C is going to be the right angle. So I'm not always going to tell you that. Now it's just something we are going to assume. The second one here is, like I just mentioned, we will round so our numbers of significant digits match the least number of significant digits in the problem. And we don't want to round in the intermediate steps. If I have 3 steps to do my calculation, I don't want to round 3 different times. We only round once at the very end. In right triangle ABC. And if you want, instead of writing down the problem, if you just want to draw your picture and label stuff in that, that's fine. So we have right triangle ABC, so I know, I told you can assume that C is your right angle from now on. Angle A is 40 degrees. Side C, remember capital letters represent angles, lowercase letters represent sides. So side C, make sure that goes across from angle C is 12. And I want side A, side B, and angle B. So this is kind of something we've done before. How would I get angle B? It's probably the easiest calculation. Yeah, we know all 3 of these add up to 180, so you could do 180 minus the 90 and minus the 40. And what do you get? 50 degrees. Okay, if I want side A, from this 40-degree angle, side A is my opposite. My 12 is my hypotenuse. So what trig function is that? So we'll say the sine of 40 degrees equals A over 12. Now before, we were dealing with angles we knew. It would be like the sine of 30, and we'd plug in a half. Do I know the sine of 40? No. If you put that in your calculator, you get a decimal. But I've told you I don't want you to round several times along the way. So I am not going to put this in my calculator yet. If I want to get A by itself, what would we do next? Multiply by 12. When you do that, it does not touch the angle. It's just out in front. So it's just 12 times the sine of 40 degrees. Now, that is what you put in your calculator. Make sure, instead, put it in degree mode. So 12 sine of 40. Okay, I get this number, but we are going to answer based on significant digits. In general, I want you to keep all of your angles to the same significant digits and all of your sides to the same. So technically, how many significant digits does 40 have? Only 1. But my sides, 12 has 2. So we're going to go ahead and go to 2 significant digits there. So what would I call this? 7.7. And it did not give you any units on that one. Okay, to find side B, one problem with rounding to significant digits, if you're going to do Pythagorean theorem, to get this side, there is a potential that you are going to be off. I may work a problem one way and you may work a problem another way, and due to rounding error, we may have a decimal that is that's slightly different at the end. So I just need you to always show me enough work that I know how you're getting your answer, so I can double check that. Let's just use a trig function. From angle A, B is my adjacent, 12 is my hypotenuse, so that would be cosine. So cosine of 40 equals B over 12, adjacent over hypotenuse. So multiply over your 12. And I get 9.1925, but I want 2 significant digits, so what will I call that? 9.2. Make sure you are rounding. You don't just cut it off at 9.1 and ignore. Round up if necessary. And so this is the first type of problem that we're going to see, where you have an angle, you have a side, you have to find everything else. Do we need another problem where I give you an angle and a side? Okay with those? The second type of problem, I'm not going to give you any angles. I'm just going to give you 2 side measurements and expect you to find everything else, all of the angles and all of the sides. This is one that we have not done like anything quite like it before. So we have right triangle ABC. Side A, so that goes across from angle A, 2.73. Side B across from angle B is 3.41. What would be the easiest thing to find here? Side C, how would you do that? Pythagorean theorem seems like a pretty good option. So let's just do that real quick. So A squared plus B squared equals C squared. Okay, so if I just type that in, we know typically if you add a square root you need a plus and minus, except will C be a negative side length? No, so you can just do the positive. How many significant digits do we want? 3. So if I round that to 3 significant digits, we get 4.37. Okay. Let's talk about these angles. We know angle C, that's not an issue. We need A and B. If I can find one of them, we can get the other one. If I want angle A, from here, this is the opposite, and that is the adjacent. What trig function involves opposite and adjacent? Tangent. So we could say the tangent of angle A equals the opposite over the adjacent. If I want the A by itself, what do you do with that tangent? It didn't just divide. What did we do on our calculator? The -1. So you are going to do second tangent and type that in. 2.73 for 3.41. Okay. I want to talk for a minute on this. There are different ways we could give this answer. I didn't specify how many significant, I told you to keep the angles to the same number of significant digits, but I didn't give you any angles. So you could go to the 3 significant digits like your sides were, in which case we would call it 38.7 degrees. There is a section of problems on the homework where it's going to tell you on a problem like this, it wants you to give your answer in degrees and minutes. If I asked for this in degrees and minutes, that would be 38 degrees. How do you get the minute portion? The decimal times 60. So let's take that times 60. Let's say I wanted just to the nearest minute. We're not going to do minutes and seconds because we only had 3 significant digits for our sides. So what would you call that to the nearest minute? 41 minutes. Okay, so whether I ask for decimals or degrees and minutes, could you guys handle that? Now I need angle B. So again, there is a difference on how you do this. Sometimes we might get slightly different answers. You could do it like we found A. You could do tangent of angle B equals the 3.41 over the 2.73. You could also subtract. We know all 3 add up to 180. 180 minus 90. So these two really just add up to 90. So you could just do 90 minus the 38 degrees, 41 minutes. So you would have to borrow. So 60 minus 41 would give us 1989 minus 38. And so we get 51 degrees in 19 minutes for angle B. So there are some different ways to get to your answer from here. Questions? Do we need another problem where I just give you two sides and you have to find an angle? Okay, let's do another one like that. Let's say we have right triangle ABC. Let's say that side C is 45.54 and side A is 23.32. I might ask you to find just one piece in this, but let's go ahead and solve for everything. That gives us a lot of practice. What would you do first? This would be our side. Side B, so Pythagorean theorem. So A squared, so 23.32 squared plus B squared equals 45.54 squared. So we have to subtract that over. Square root. How many significant digits do I want? 4. So we will call this 39.12. And if I had given you a measurement like inches or feet, you would go ahead and include that label. Did we get that side okay? Let's say I wanted angle A. From angle A, 23.32 is opposite, 45.54 is hypotenuse. So what trig function involves this? Sine. So I could say the sine of angle A equals the opposite over hypotenuse. If you need the angle, that's when you do the inverse. Okay, so you should get this lovely thing. If I said to round it to 4 significant digits, you would tell me 30.80 degrees. If I said degrees in minutes, then what do? Decimal times 60, which would give you 30 degrees, 48 minutes. So just be prepared to answer either way. From that, if I wanted angle B, I know A and B have to add up to 90, so I could just do 90 minus that. So borrow. And we get 59 degrees in 12 minutes. thing I do want to mention on significant digits. If you had something like 59.99, and I told you to round that to 3 significant digits, then it would become 60.0, right? If I said you had to round this to only 2 significant digits, if you give 60, how many is that? That's 1. But 60.0 is 3. If it's impossible to give the exact number of significant digits you need, you go with less. So if I want 2 significant digits, I would be forced to use the 60, which only has 1. Does that make sense? So sometimes due to rounding, it's impossible to give it to the exact number. Go smaller, not bigger. All right, any questions about those? I want to look at some word problems now. And in these problems, you're going to hear me talk about angles of elevation and depression. The key for both of these is they are measured from a horizontal line. And then it's what you think. Angle of elevation, it starts at a horizontal. Elevation would mean up. So it's from that horizontal line up. Angle of depression, you're starting from your horizontal line and going down. So the key for both of those to work, though, it has to be from a horizontal line. The angle of depression from the top of a tree to a point on the ground, 15.5 meters from the base of the tree, is 60.4 degrees. Find the height of the tree. Probably pretty difficult just to read that and know what to do. But let's kind of break it up. So we're talking about a tree. Okay. I am quite the artist. So there's my tree. Okay, I have the angle of depression. What do you know about an angle of depression? Okay, it starts from a horizontal going down. So am I at the top of this tree or at the bottom? We're at the top. Okay, so I've got this horizontal coming from the top. So from there down is what angle? That's crooked. This would be the 60.4 degrees. It's from the top down. I know this point on the ground is 15.5 meters from the base of my tree. So this length is 15.5. We are trying to find the height of the tree, which is this thing. So I am looking at this triangle right here. Do we have, first of all, we can't use our trig functions unless it's a right triangle. Is this a right triangle? Yes. Where's the right angle? We're going to assume this tree grew straight, so it's where the tree meets the ground. Okay. I want the height of the tree, so that is like my x. I have 2 sides. I need an angle. Is the 60.4 inside my triangle? No. We have 2 options for getting it, for getting an angle inside the triangle. Can you tell me one of them?
If you take 90 minus 60.4, you get that top.
So 90 minus 60.4 is?
106.
Now you have that top angle in your triangle. So then we could do a trig function. From there, 15.5 is opposite. The side I'm looking for is my adjacent, so what trig function would I use? Tangent. Let's see. Tangent of 29.6 degrees equals 15.5 over x. Trying to solve for x, if you want to get rid of your fraction, though, you have to multiply by the denominator. And then what do we have to do? Divide our tangent. How many significant digits will I use in my answer? 3 is what we had in the problem. So you get 27.2849, so we'll call it 27.3. What would my unit be? Meters. You could have also gotten this angle down here. Those are two parallel lines. This would be a transversal, so alternate interior angles. This down here would be 60.4. You just have to be able to find one of them though, so it doesn't matter how you set it up. Alright. Question? I'm going to give you one more. I want you to try to draw a picture and see if you can set this up for me. Have you been able to draw a picture of what you think it means? So let's check your picture before you do too much. We have a flagpole. There's my flagpole. The length of the shadow. Okay, you're gonna laugh, but if I put this question on test, I guarantee a lot of people will miss it. Where does the shadow go? On the ground, right? I always have people that label the hypotenuse as the shadow. Your shadow is on the ground. So I'm talking about, we've got the sun up here. I'm talking about my shadow, so that's going to go on the ground. Okay. We know that the length of the shadow is what? 27.65, and we know the flagpole is 55.20. So how many significant digits? 4. Find the angle of elevation of the sun. Angle of elevation means from a horizontal up. So is that going to be inside my triangle or not? I'm thinking, there's my angle to the sun from the horizontal. This is the horizontal, it's on the ground. Going up, this time it does fall in my triangle, doesn't it? So that is the angle I'm looking for. I'm going to call that theta. What trig function would you use? Opposite over adjacent, so tangent theta equals 55.20 over 27.65. If anytime you want the angle, that's when you do the inverse. We are just going to give our answer as a decimal with 4 significant digits. So we get 63.39 digits. Any questions there? I know I'm teaching most of the class, but I want to do one last type of problem, and then that's the last thing, okay? Look at this one. So I have given you this picture. From A to D is 32. We are looking for X here. How many right triangles do we have? 2. You may not need to draw them separately. I am just to make this clear as I walk through it. We have BCD. And we have ABC. Those are both right triangles. In this one, I know this angle is 54. This is H and that's X. Over here, angle A is 38. This is H. What would this entire length be? Do I have enough information in either triangle to find my X right now? You need at least 2 pieces of information, whether it be 2 sides or an angle and a side. Do I have that in either of those? No. Okay. Let's see what we could do. From this 54 degrees, H is my opposite, X is my adjacent. So what I could do is say that the tangent of 54 degrees equals X over, opposite over adjacent, H over X. If you want to get rid of the fraction, you can multiply your X over. But then we're pretty much stuck because I don't know X and I don't know H. Let's go to the second triangle. What could you say from there? Tangent of 38 degrees equals opposite over hypotenuse, H over X plus 32. I took each of these triangles, and from the angles we had, I just set up the tangent ratio for each of them. If I wanted to get rid of the fraction here, we multiply over the X plus 32. But I'm stuck again, because I don't know H and I don't know X. However, look at those 2 equations. What do they have in common? They're equal to the same thing. So they're equal to each other. So, since both of these are equal to H, I just set them equal to one another. And now I have an equation that only has one variable in it. It's a little ugly, but we only have one variable. We can solve this. The first thing you're going to have to do is distribute that tangent. From there, how many terms have an X in them? 2 of them, so we need them on the same side. Okay. We can't combine these, they're not like terms, so what could you do? Take the X out. And then you have x times something, so we can divide. When you put this in your calculator, you need to be extremely careful. Every time you push a trig function, it will open a parenthesis. So you have to make sure you're closing that. You also need a set around the entire numerator and entire denominator. I would like for everybody to try to plug this in exactly as I have it written. If I wanted to give this, I get 42.0119. How many significant digits do we have in the problem? 2, so we would call this 42. That one is definitely a step up from all the other problems we've done. You're not going to have any quite that complicated on your own yet. I think it'll be the next section before we have any like that on our homework, but I just wanted to go ahead and kind of show you what that would look like. Are there any questions for me? So, we are at the end of this section now. There's 10 problems for homework. You guys have about 10 minutes right now. This is not going to be due until Thursday. Tomorrow you will have class time. Don't expect a full class. It'll probably be about half a class period to work on it. And then I will start the next section, but you will have some time in class